Right, I'll just show again for any beginners that are looking into putting LEDs in to things like radios like this. This is an old Sanyo from the 80s, and again, same as I mentioned in the last video, it's got the same problem where you can't see the actual dial pointer through the actual plastic here, because there's no backlight of any sort. So looking at this, the dial string doesn't go any further along than this. It stops here, and there's a little gap where I can just fit in an LED right at the end, and it doesn't go any further to bump into the LED. So I'm hoping that will work, and I'm just using some British Telecom extension wire that I'm going to solder onto the LED at this end, and I found a route that I'm going to run the cable, which is in this crease of the battery compartment here, which can come through this gap, and then with the mains on. So this is just to give an idea of what you find. Ideally, I'd like to have found a suitable DC point here, but this is in the radio section, so it's probably quite low anyway. But basically, there's a couple of rails here. Just if you're doing this at home, because obviously this is for beginners. Again, I'm going to turn the mains on. This is a mains transformer right here. Again, this is the figure of 8 cable comes in. It's pretty well insulated from any live points on here, but just be careful, be aware of where your fingers are in relation to a mains transformer if you're going to be working with it live. If you want to be really safe, put batteries in the battery compartment and don't use the mains. I don't have the large batteries for this old unit. I don't know what, I can't remember what they be, PP3s or whatever they're called, the bigger round ones, about 1 inch diameter, 3/4 of an inch diameter. There's 4 of them that will be required for this unit. So basically turning the mains on here and just going onto the 20 volt range of my voltmeter here, I found that there's some rails here, there's some link cables, link wires in here, one of which is earth, and obviously be very careful here, there's the mains transformer, and you can see I've got 12 volts, 11.9 volts on 2 particular wires that I can solder to. Just turn that off. So I can pick up there and just solder onto those wires with a bit of flux and strip this BT solid core mains cable, which is a 0.5mm BT cable for any people like me who used to work for BT, who know that that's 0.5mm. It's the same sort of stuff that you get in Cat5 and whatnot. It's a twisted pair cable. It's solid core, but it's quite thin. The two wrapped together. I've just twisted them together here because these were from an old extension cable, which isn't twisted. But so I've twisted them together. I'll probably put a piece of tape. I'll probably glue them. I'll just put a blob of glue here to hold that down so that it can't move once this is in to here, and then solder on. So now I'm going to prep the ends. So I'll show you how that's done. Well, it's not really much to show. What I'm going to do is strip the ends enough to solder onto. I found this is a yellow LED. I've got a white LED here, which are the same as the last one. I forgot to mention in the last video about the different types of LEDs. I said I went on the premise of 20 milliamps through an LED. That's for the older types like this one. But most of the ones now are really efficient. They're called high brightness LEDs, and they can run down to, I think it's 3 milliamp or through 2 or 3 milliamps. So the resistor that you'd have to have in series with those would have to be 10 times higher than these. If these take 20 milliamps to more or less. And it's not exact. It's not important particularly, but the consideration of high brightness over the normal ones is if you are going to be running your unit on batteries, because obviously you don't want the LED to be using your battery unnecessarily, especially on a small transistor radio that should inherently be low power anyway. You don't want it all burning up using an LED unnecessarily. So this one, I'll use the same principle as last time. I'll be dividing, in this case, the 12 volts that I've got here, I'll be dividing that by the 20 milliamps or 0.02 amp. To get the resistor value for that. So just briefly, which you won't be able to see on the screen here, if I divide, I'm pulling up the calculator, if I divide 12 by 0.02 amps, I get a 600 ohm resistor, so more or less twice as much as the last one, which you'd expect because it was running at, its calculation was done for 7 volts on the last radio, and this one I'm doing for 12, so it's more or less twice the voltage, so you'd expect twice the current to be put through the LED, in which case you'll need twice the value resistor to limit it to the same brightness as the last one. Okay. If you're going to be stripping cables, I'd invest in a good quality cable stripper like this. It's this one I got from WorkZone, I think possibly Lidl or somewhere similar, I can't remember exactly now, which in these types basically just put in, they do variable diameter cable and do a pretty good job, and just, they don't put the same sort of, they don't stress the cable as much as if you're using strippers like this, which you can obviously then put nicks in, especially solid core, half mil stuff like this. So I'd recommend getting one of these because they just make life stripping cable so much easier. They're varying diameters, and they've got to stop here for different lengths, or you can just pass through like I did. I think it was, I don't know, something like 12-ish pounds or so. So worth having a decent cable stripper if you're going to be doing any type of electrical work, obviously. This is the cheapest half decent soldering station that I found locally. It's the manufacturer's name is Eagle. I bought this from a little shop down the road from me here in Cornwall called Warrior. It was the only one that was in over Christmas. I've bought a cheap Chinese rubbish, of which the base was this, and it literally lasted one night before the ceramic tip of the attached soldering iron just snapped off with its own heat. Just don't bother trying to buy cheap soldering stations. I mean, yes, this one's cheap, but certainly the Chinese stuff, as we should all know by now, practically everything electronic that seems like a good deal, but it's cheap from China, you're just throwing your money away 9 times out of 10. Most of it is complete garbage. The only thing I'm still using now is the brass cleaner, the brass filings in here for cleaning the tip of your of your soldering iron, because the rest of it's just garbage. So don't bother. So this one, again, if you're going to be doing any kind of electrical work, you do have to invest in a half reasonable soldering iron. So this one was about £50. I think it's 48 or was it 42? I can't remember now, but 40 to 50 pounds for this unit. Variable temperature, which you need for obviously soldering different masses because of the heat that will be sunk into connections, especially like earths where there's a lot of copper mass involved. So therefore, it would take longer to heat up the copper before you could solder to it, and that type of thing has to be taken into consideration. So you need a variable temperature unit really, and this one's is pretty good so far. I've had it for about a week, and I'm not can't say I'm displeased with it. It does the job. I haven't changed the tip yet. The tip's a bit big for most work, which you probably can't see. I said, unfortunately, I'll probably have to if I'm going to do more of these videos, I'll get a better camera, because this overhead one, it's just a cheap webcam, so it's not, and I can't zoom in, and obviously its ability to autofocus is probably limited or just doesn't work. So basically, that's the sort of size tip I'm using at the moment. If you're going to be doing finer work, circuit board work, then you'd want one with a much finer tip. So try and get a unit that comes with different size tips, or certainly interchangeable tips that you can buy and change to get the really tiny, slightly curved one. That's good for really fine work. But this is a general one, does for most of the stuff I'm doing at the moment, which is sort of radios of this size, or the valve amp radio that I finished a few days ago, which is just sold on eBay. So I'll be getting rid of that tomorrow. And this can get hot enough to do point-to-point work, just about. I think the maximum temperature on this, it goes up to 480 centigrade. It claims, obviously these aren't accurate, most of these, so you probably have to tweak the temperatures just to do some tests first to find out what's the best temperature, or just what's the best number for the particular work that you're doing, and not really pay too much attention to the exact number in terms of degrees centigrade, because they're generally not that accurate. So that's the unit I'm using at the moment. So I'll just solder these up, and I'll show you the heat gun that I've got, which I got in a boot sale, which is a Bosch two-stage heater, which I'll put some shrink downs on. So I'll show you that in a minute, and then I'll also show you my desoldering, my solder sucker unit that I have from Circuit Specialist, which is a desoldering station as well. Okay, you can check which is the anode, which is on the LEDs. It's usually the long leg. So that's where the positive voltage would connect to, but you can check, say yours has been cut and they're both the same length, something like that. You can use your voltmeter on the diode testing setting and just touch both the legs, and you should see the diode light up accordingly. If you're just starting out and you've only, say, picked up a cheap soldering iron or like a kit or something, and it's got lead-free solder in it, it's absolutely rubbish. Again, under this the nonsense of health and safety, rubbish taking lead out, but personal opinion there. But as far as soldering goes, there's no question. Leaded solder that's got the resin core in it solders far better than this lead-free rubbish. But this is all I happen to have to hand at the moment as well. So what I always use a bit of liquid flux. This is just some, again, stuff that's off eBay. I find it quite good. I prefer the liquid stuff. It just comes in a little bottle with a brush, so you can just dab both of the surfaces that you're going to solder, and it just helps. You never get a shiny result with this stuff. But it just helps to get that initial connection if you're just soldering two wires together, at least anyway, or any other application really. Just always best to use a bit of flux with solder if possible. Before you solder, don't forget to put shrink downs on. This is my Bosch heat gun that I picked up in a boot sale, I don't know, £5 or something. Good quality being Bosch, so can't do much better than that for cheap. Right, well, after a bit of a jiggery pokery there, the first white LED started to flicker after I'd soldered it in series with the 1K resistor. So I mean, it's out of an old junk box, so who knows. So I've had to go with the yellow one, unfortunately, but who knows, it doesn't really matter. It's just whether it works, whether it's bright enough to see the needle. So plugging it back into the mains now, you can just see LED lit, so I'm going to put the fascia on and have a look, see what it looks like, how clear it is next to the needle. Well, unfortunately this one didn't turn out as well as the other one, because I don't really like the colour, but it's also not as effective because obviously the actual LED is in line with the plastic gap, so really visible. So it hasn't really illuminated anything like you'd want a needle to illuminate, but anyway, still better than nothing. And I've got the horrible job of trying to put this back together with the handle in, which is, it's just an absolute pig of a unit, this thing, to get back together again. I'm lining everything up and getting the buttons in at an angle and stuff. But anyway, that's how it turns out sometimes with electronics. You make one mistake and kind of things spiral into just worse sort of scenarios, really. So there's a lesson in itself for beginners. You know, it can things can go well, and then sometimes they just go badly, and you end up backtracking and then make more mistakes and stuff like that. I prefer the white one. I might change it. I think red. Maybe tomorrow I'll change it to red, so it's not quite such a horrible colour, and also maybe not so obtrusive as the bright yellow. So anyway, but that's the finished item at the moment.